everyone, and welcome to an XTIVIA webinar, delivering the information you need for the business future you want. We're sharing our knowledge to help your business thrive in today's new normal. My name is Alex Killian, and I'm the video producer here on XTIVIA's marketing team. And today you'll be hearing from some of XTIVIA's API experts. Before we dive into the webinar this morning, I would love to tell you just a little bit about our company. For nearly 3 decades, we've been providing a variety of IT services to hundreds of businesses in countless industries. If you can imagine the business outcome, XTIVIA can create it with technology. And with that, I'll go ahead and pass it over to Bill Marcial.
Thank you for joining the API Gateway and API Management Overview. We have Manny, who is an integration architect at XTIVIA, who will share his experience working with clients implementing open source API gateway solutions. Manny, when working with the numerous clients you work with at XTIVIA, what are some of the open source tools that clients tend to request in their implementations?
So let's talk about open source API gateway and management solutions. So far we have seen the Azure side, the platform integration side. So let's dive deep into the open source API gateway. So XTIVIA has a broad set of experience when it comes to open source API gateway and management. We have expertise across different deployment model, which includes cloud native, on-prem, and even Kubernetes native. And what we have seen so far in the market, which is trending today, is we see a lot of Kong implementations, and very closely following with that is Spring Cloud Gateway. We also see for advanced client who are getting into that Kubernetes ecosystem, we see a lot of Ambassador implementations. Tyke WSO2, they were there before in the market, and they were open source. They are still open source. They also have a commercial version to it. But as I mentioned, Kong Cloud Gateway and Ambassadors is what we have seen in our experience. Coming to specific experience, which we'll be covering today, we'll talk about Spring Cloud Gateway in specific. And to your right of the screen, you see the diagram there, and that's the Spring Cloud Gateway implementations. And as you see here, if you look at this diagram, you see there is a API gateway layer which is sitting on the perimeter and which is interacting with the consumers. It can be any kind of consumers or external clients, can be browser-based, mobile, or IoT, or it can be just a thick client too. And all this to your right-hand side is the complete Spring ecosystem. The great thing about Spring is it's a pretty mature open source platform, widely adopted, has a very strong community backing it. So what does that mean is that you get all the latest and greatest innovations from the open source world and elsewhere, and kind of getting a first-hand experience to that, the new and the innovative technologies happening around the world. That's something unique what I have seen so far, which is not there in other open source projects where you may have a less number of contributors, may not be backed by a strong company. There may not be a strong consortium of things that may not be even graduated through the CNCF Foundation. So all in all, Spring has a great ecosystem, unmatched and unparalleled to any other open source platform. And that's why it's the leading implementations. It's kind of a synonym for open source implementation when it comes to microservices and API gateway or management. So let's go into the different pieces of Spring Cloud Gateway. And as we know that Spring Cloud has a broader ecosystem, and which includes the config servers for distributed tracing, service registry, circuit breaker dashboards, and even many other features which kind of encapsulate the overall Spring Cloud ecosystem. But what is unique about Spring Cloud Gateway, it is implementing all that which Spring offers, the Spring Cloud offers, inside of Spring Cloud Gateway. So it's kind of the best of the Spring Cloud is kind of packaged together and wrapped, and it's called a Cloud Gateway. So let's go one by one. As we know, to any basic or any API gateway, there are few things which are pretty common, which includes you must be having a proxy mechanism which you are kind of proxying the traffic to your backend microservices. And while you do that, you kind of set up different path for those incoming requests. If your incoming request comes with a certain path, and you should be able to match and kind of redirect the traffic to your backend, right? And while you do that, you provide different set of filters or apply some security policies, or you want to do some rewrite of the URLs. All of that is a core feature of any gateway, and which is what Spring also offers in a way of routes. So pretty much you can define the routes, which will tell the API gateway to redirect the traffic to different backend services. So you pretty much kind of shielding the client from knowing what is behind your API gateway or proxy. So, and then the predicates is basically your path matching. Just matching the path of incoming request, and then kind of reroute the traffic to the certain backends or the microservices. And the filters, you want to extract some values from the URL, or you want to overwrite the URI, or you want to apply certain rate limiting features, which are also core to any of the gateways. So all that you can do using the basic features of Spring Cloud Gateways, the routes, predicates, and filters. So, and coming to the next one, with any other gateways or API management solutions, you need to have a great portal, like a development portal, where you can have a documentation for the APIs you are exposing. You should have also a kind of a client, like a test client, so that you can provide that testing feature to your end users. They can play with that API before even they consume that API. So for that matter, Spring Cloud Gateway offers a kind of a easier integration with Swagger UI. So what that helps is to provide the documentations and then kind of a testing clients for the APIs. So pretty much kind of a portal-like feature. And coming next is the service discovery, and this is unique. And why? Because service discovery, as we know, in a typical microservices architecture, you may have somewhere around, let's say, like 50 to 100 microservices, right? And really, someone has to keep a track of where those microservices do exist. So Spring Cloud Gateway offers the service discovery mechanism. It kind of integrates well with the service discovery framework offered by Spring, which is the Eureka framework, kind of open source by Netflix. So Spring Cloud Gateway neatly integrates with service discovery feature of the Spring Cloud ecosystems. So that kind of offloads the Cloud Gateway from managing that service discovery and registration. So at the end of the day, you would like to have your gateway more resilient, and for that matter, Spring Cloud Gateway also integrates with the Spring Cloud framework feature, which is called reliability or the circuit breaker. So what these two together offers a greater reliability to your cloud gateway. You don't want your cloud gateway to be a single point of failure, right? So, and you want that to be performing faster, right, in a non-blocking manner. And I missed to tell you one thing, that the whole Spring Cloud Gateway is kind of built upon the Reactive Framework, which is based on Project Reactor. What that offers you is a non-blocking calls. Your threads are not blocked. So that helps to kind of improve the performance of the gateway. You don't want your gateway to kind of be a single point of failure or kind of choke your traffic, or in a thread blocking way, right? So you want the minimum time spent in your gateway while offering all the features, securities, policies, and routing features, all that without sacrificing the response time. For that matter, it's built on Project Reactor. And I would like to also mention one thing here. Spring Cloud Gateway used to be based on Netflix Joule. It's no longer supporting Joule. I mean, it's a complete rewrite of the whole gateway features. It does not include the Joule 2 also. It's a completely rebuilt or re-architected product, which is developed by the Spring community. And I was coming back to the reliability features, which everyone should look for, is offered by the reliability and circuit breaker pattern. And there are many underlying tools which is offered by Spring Cloud ecosystem, and they are Resilience for J, which is based on the Netflix Hystrix platform. Well, it's not exactly based on, it's kind of evolution of that. It's the same mechanism, same theme, but it's a much better than its predecessor, which is the Netflix Hystrix. So these are the core features of Spring Cloud Gateway. Any questions before I move? Okay, so I guess that is no. So moving on, we have expertise in Spring Cloud. Just a slide back, please. The previous slide, please. Okay, so let's talk about the Kubernetes. Nowadays, with the proliferation of microservices and the cloud native and also cloud agnostic platform, so things are more relevant when we build our platform to be cloud independent, right? So in that case, Kubernetes plays a big role, as we all know, and Spring Cloud Gateway also integrate nicely with Kubernetes using Spring Cloud Kubernetes starter. But it can be, Kubernetes has its own platform when it comes to the gateway, and we'll talk about that in the next slide. We'll also talk about the Istio features, which integrates well with Kubernetes. Okay, let's move to the next slide, please. Okay, so what you see here on the screen is a reference architecture for an API gateway using service mesh, and all of that is built on a Kubernetes platform, right? And this reference in this reference architecture, I have depicted the API gateway to be the Spring Cloud Gateway, which we just talked about, and for service mesh, we are leveraging Istio. So if you see here, your incoming request came through a load balancer, and then it's going to your DMZ, where you have your API gateway, which is facing all external clients. That is located, and what it offers you, basic features like access control, identity brokering, security, and monitoring. That's all. But the more features are offered inside of your network, and because these are mostly security control features, that's why it's residing on the DMZ facing to the external client. But once it goes past that, it comes to it's hitting your Kubernetes cluster, right? And if you see in a Kubernetes cluster, everything is a pod, as we know. And this example is just a sample example here, and you see there are different parts. A pod, you see order pod, patient pod, documents pod, various kind of pods here. And in that pod, we are co-locating the Spring Boot applications here. I mean, you can have anything, because once you put any thing in container, you kind of create a level playing field. Doesn't matter what is inside the container. It can be a Node.js, can be or a .NET, can be a Java, can be a Spring Boot, or anything for that matter. So here I'm just depicting Spring Boot here. So you see there is a Spring Boot container in the pod, and you see there is an Oracle container database. And to that side is a little one here. It's called Envoy, which is a sidecar proxy. So that helps you to kind of a micro gateway, so to say, which offers all the cross-cutting concerns between the service to service call. And you see there's Istio service mesh also, which is also for, so let me introduce you to service mesh. So we talked about API gateway, which is kind of all about the traffic which is flowing from north to south. And it's kind of pretty much residing at the perimeter, right? When it's mostly external client facing, right? Or can be client facing, doesn't matter, external or internal, it's a client facing. But when we talk about service mesh, it's a east-west traffic. That means it's kind of providing a gateway features, but within the service, like inter-service communications. That's the promise of service mesh. So with the proliferation of microservices, right, someone has to provide that cross-cutting concerns. Like one service, let's say a service deciding on order pod is trying to call the patient pod, right? And we know patient pod is a secure one. And we don't want that. We want to handle all those cross-cutting concerns like security, throttling, and access control, monitoring, all that. And how do we do that? So that's where Istio comes in with its service mesh, and which provides the similar to what we just saw previously with the Spring Cloud gateway, the ecosystem. It offers you a service discovery, circuit breaking, traffic management, authentication, security, policy, and telemetry. All that, which we typically see in an API gateway, it's also offered by Istio here. So we'll talk about what you just noticed here within the last 2 slides. There are overlapping features. So you really need to think and not get confused by okay, Spring Cloud Gateway or any gateway offers me a service discovery. It also provides me a traffic management. Why do I need a Istio? So the answer is like Istio has a different use case for a different scenario, which is between the service communication, like inter microservices communication only, not for external facing clients. And also in this architecture, you see there's ingress gateway controller offered by Istio also. Kind of controls the traffic which is moving in to your Kubernetes cluster. It provides what many security mechanism at your inbound traffic, which is to the Kubernetes cluster. Okay. And also just to mention one more thing here, this is a reference architecture just leveraging Istio, but you're not limited by the choice of your tools. You can also use Linkerd or Consul instead of Istio service mesh. So here is a word of caution. We have seen like the various tools you have in open source world. It's a lot. So an open source tool set is not for everyone. There are few. You really need to qualify for these 3 things so that you know what you're kind of signing up for, right? The first one is highly innovative and agile culture, like an organization which is kind of fostering innovations and is very agile can really succeed in open source adoptions. It may not be so before you even start getting a tool, you really need to have this kind of culture in your organization. So there is a need of a bit of culture shift if you're not, before even you try open source. Because what happens, open source is changing every month. And there are new tools come in, the tools come in, tools go out. And there's always a new thing. And the main thing here is like, because innovation is the key differentiating factor when you want to like create that edge in your market space, right? So that can be differentiating factor between sustaining or kind of going bankrupt, right? So your innovation is what saves your business. So if you're really innovative, go for open source, and with an agile culture, so which kind of fosters that you have innovation plus an agile, which you kind of not shy of making changes, but you embrace changes, right? So you like changes, you know the risk, you know the dependency, you have a well team, you have a niche engineering talent, which is our second point. So it's not for everyone, as I said, but again, if you really have a niche engineering talent who kind of does not shy away from trying new things and also knows what is the pros and cons, and at the same time, you also need to have a ecosystem or a kind of a governance mechanism, right? So just because your new developer X likes a tool he just learned from a meetup doesn't mean that you can really productionize that, right? So there are some checks and balances you need to do, and you need to have a governance around what tool qualifies for your business case, what tool may not qualify. There may be competing features within that tool. You really need to have a good engineering talent to kind of support that adoption, and at the same time not shy away from innovations and not shy away from that agile mindset. The third thing, the driving force, what we see in our open source API management adoption across various clients is the need to be vendor independence, right? So you are not depending on your vendor for releasing a feature which is already out there, right? So, because what happens in an open source world, the feature comes pretty quick compared to a vendor which has a release cycle of every 6 months. You may be losing on that to get the newest feature which is already happening in the world, in the tech world. At the same time, vendor independence also means that you are not locked to a vendor, and your licensing fees will significantly reduce. So at one point I would like to make here is like, just don't think your cost as just licensing. Your cost can be an overall cost. Licensing cost is just one part of the cost. There are resource costs, there are opportunity costs, there are many costs you really need to understand when you go for open source.
Thank you, Manny. This concludes our session of API Gateway and Management overview. If you have any further questions, please contact us. The contact information is below. Thank you very much, everyone.
Thank you so much for joining our webinar this morning. If you have any further questions, please don't hesitate to reach out. We're happy to answer all your questions. And as a reminder, this webinar and all of our previous webinars will be available in our on-demand webinar library on our website. And you can look forward to a new XTIVIA webinar the 4th Thursday of every month. And if you subscribe to our YouTube channel, you can check out all of the other resources we have going. We've got some really informative demo pieces and a lot of great content coming out. So check it out. And thanks for joining us this morning.